Example 3. Find the exact value of the cosine of pi over 2 minus theta. All right, so let's take a look here. Cosine of pi over 2 minus theta. Now this one feels a little bit different because although pi over 2 is an exact value, it actually is a concrete or a constant angle. Theta is just a placeholder. So what we're actually looking for in this situation is to establish a new identity. And in order to establish that new identity, I'm going to use my rule for the difference of the cosine. So in my scenario, my alpha is pi over 2, and my beta is theta. Hope that doesn't sound confusing. Let's see here. So I'm going to say that this is equal to the cosine of pi over 2 times the cosine of theta plus the sine of pi over 2 times the sine of theta. So what is the cosine of pi over 2? The cosine of pi over 2 is 0. And cosine of theta, I don't know anything about that. The sine of pi over 2 is 1, and the sine of theta I don't know anything about. The 0, the first term, wipes out, and so I'm left with the sine of theta. So I end up saying that the cosine of pi over 2 minus theta is equal to the sine of theta. Is this result familiar or true? Convince yourself with a specific angle. Well, I think maybe to convince ourselves, instead of using pi over 2, how about if we said 90 degrees? Okay, can we do that? I mean, they're equivalent. One's in radians and one is in degrees. So let's convince ourselves. Give me a theta. How about if theta was 30 degrees? If theta was 30 degrees, then we would be saying that the cosine of 90 degrees minus 30 degrees is equal to the sine of 30 degrees. 90 minus 30 is 60. And I believe that we saw earlier that this is a true statement. What is the cosine of 60 degrees? It is 1/2, and this is also 1/2. So this should feel familiar. We've done something like this before. So that leads us to example 4, which are cofunction identities. So what we're going to do is find the exact value of the sine of pi over 2 minus theta using the result that we just came up with for the cosine of pi over 2 minus theta. We said that the cosine of pi over 2 minus theta is equal to the sine of theta. So how can we use that to find out what the sine of pi over 2 minus theta is? Well, let's see here. What I know is that whatever is in this position for sine of theta is also going to be in this position for the cosine of pi over 2 minus theta. So if what I have is something bigger than theta, then what I can say is that the sine of pi over 2 minus theta is going to equal the cosine of pi over 2 minus the thing that I just circled, right? Those two have to match up. And so I'm going to put pi over 2 minus theta. And so let's see here, what does that leave me with? If I distribute that negative, I get pi over 2 minus pi over 2 plus theta. And pi over 2 minus pi over 2 is 0, and so I end up with theta. In general, we can say that if two angles are complementary, Complementary means that they add to 90 degrees, or if we're in radians, pi over 2. If two angles are complementary, like we saw with the 30 degree and the 60 degree angle, then the sine of one angle is the cosine of the other angle, and vice versa. These are called cofunctions. So, a new identity. The cofunction identity says that cosine of pi over 2 minus theta is equal to the sine of theta, and the sine of pi over 2 minus theta is equal to the cosine of theta. And that's going to come in handy in a couple of different cases.